Welcome, and thank you for joining this webinar, Invisible Power, Infinite Scale, How Ambient Energy is Pushing the Battery-Free IoT World, prepared by Alpert research team.
Today, we are peering into the future of connectivity, a world where the battery, it just vanishes entirely.
It really does sound like science fiction, doesn't it? We're talking about the zero energy revolution, it's a fundamental paradigm shift that cuts that physical tether of power. What is the central problem that this entire field is trying to solve?
It's the battery constraint,
Yeah.
and it's a problem that has just scaled horribly as the Internet of Things has grown. Operationally, it means huge maintenance costs. In remote places, harsh environments, you have to budget to replace every single one of those batteries. It puts a hard limit on the operational lifespan. So let's start high level. Why wireless ambient IoT, and why is this zero energy approach mandatory now?
The biggest flaw, by far, is the physical dependence on the battery. Traditional IoT is fundamentally unsustainable at the scale we're anticipating. We're talking trillions of connected devices. The strategic drive is moving from battery-dependent, high-maintenance solutions to self-sustainable, maintenance-free solutions. We have to address the unsustainable costs, the immense labor of maintenance.
But let's talk dollars and cents. What's the economic disruption that moves AIoT from a niche curiosity to a mainstream strategy?
It's the cost per unit, amplified by scale, and the removal of labor costs. A typical massive IoT tag, using technologies like LTE-M or NB-IoT, usually falls into the $5 to $15 price range. An ambient IoT tag, built purely on ultra-low power components and backscatter, can drop to an anticipated high-volume cost of 10 to 50 cents.
That is a difference of 2 orders of magnitude. I mean, that doesn't just enable new use cases, it redefines entire business models.
And if you consider the full life cycle, including the labor costs for periodic battery replacement over 5 years, the total savings achieved by AIoT can be $50 to $200 per device. This zero battery replacement labor, that's the hidden economic incentive. And this huge cost reduction suddenly unlocks scenarios that were previously just dismissed as too expensive or too large.
So let's formally define this paradigm shift. We know the IoT landscape: broadband IoT for high throughput, critical IoT for low latency, and massive IoT. Where does ambient IoT or AIoT sit in this categorization?
AIoT occupies the very low end of the IoT use case spectrum. It is not about data rate or low latency. It's all about ultra-low complexity and ultra-low energy consumption. And crucially, 3GPP defines AIoT devices as having batteryless or severely limited energy storage capability, as documented in TR 22.840. This really is the next epoch. It requires completely different engineering constraints than even NB-IoT.
The ambition here is to operate devices with near zero to actually zero onboard primary energy. We are literally talking about devices designed to operate with an output power that's typically between 1 single microwatt and maybe a few hundred microwatts. And it demands a complete overhaul, not just the radio, but the entire operational stack. You can't have one without the other, which is why we always link AIoT with NZEC. The communications protocol is what makes that microwatt power budget even possible. Why is that 1 microwatt peak power constraint so crucial?
It's the maximum power that can be realistically, reliably, and consistently harvested from ambient sources using a tiny integrated harvester. If your device peaks higher than that, you have to use a larger battery, and you immediately fall back into the MIoT complexity and cost bracket. When we say zero energy devices, or ZEDs, what are the, say, 3 non-negotiable characteristics?
First, they have to be maintenance-free. Second, they are by definition resource-constrained. And third, they have to rely on harvesting energy from their environment.
And crucially, no batteries.
Crucially, they are either completely batteryless, meaning zero chemical batteries, or they have extremely limited energy storage. Often they're just relying on a tiny capacitor or a supercapacitor. We usually call them CSCs. So this zero energy ecosystem relies on 3 technical pillars.
The 3 key enablers are, first, energy harvesting, or EH. Second, ultra-low power communications, which is primarily backscatter. And third, energy-aware computing. If any one of these pillars fails to optimize for intermittency, the whole system just fails.
I think the key strategic takeaway is that shift in market dynamics. This technology fundamentally transforms what used to be an operational cost for a network operator, blasting out a radio signal, into a monetizable service, providing wireless power. This movement creates new ecosystems where the manufacturers and retailers who actually own the sensor data become the new data hubs. They create value in a way that's separate from just providing connectivity. It forces a total reassessment of where value lies in the entire IoT chain. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.